Good night, everyone. My name is Jorge Castro. I'm going to present our project MAC24. The integrals are Antonio Rodriguez, Ángel Flores, Jonathan Mendez, and myself, Jorge Castro. For today's presentation, we're going to present a little bit about the introduction, architecture, some components, our results, what is the MATLAB, videos, and our conclusion. Introduction. Our goal is to design and develop a system based on microprocessor skills. That's for our class Microprocessor 2 on PIC18. The system is composed by a robot and our PC. The robot is MAC24. It's based on Crazy's RP5CH02. The system in the future, our goal is to help to detect and scan any kind of place that at this moment can be accessible for us. Create a map or road of this location. This is our system architecture. Like I said, it's composed by a PC and a robot MAC24.
The component that we use on our system, we have a PC, and the PC has the software that is in charge to gathering all information that is coming from the PIC. On the PIC, what we are doing is just taking information from the Sonar, and through the RF communication, we are passing on the information into the software, which is in charge to evaluate the information and determine the position of the robot. Here we have two PIC. One of the PIC is in charge to capture all the information from the Sonar, and the other information is in charge to send information into the PC. The second one, which is in charge to send information to the PC, is doing through the RF communication. So we are using wireless to communicate between the robot and the PC. Okay, here we have in more detail what we were doing. We have one of the PIC which is connected to the Sonar, and we have the second PIC which is connected to the RF communication. So this one is only taking care about the position, and that one is taking care about the information that is to be sent to the PC.
Basically, this is our Sonar. It detects the object, and the output of the Sonar basically is a voltage. The voltage is proportional to the distance. And this is our RF module. It is used to send the information from the car to the PC.
And then we want to do a matplot of the information gathering from the robot. So a map must be plotted from the robot, and it may have further application I explained before that can be any kind of surface detector, so you can get what is on the surface. So what is the pseudogoal of that part? Before we are going to receive the coordinate that is from the robot, and then we're going to, depending is north, south, northeast, and the other, we are going to then traduce that into coordinate like 0, 0, 0, 1, 0, 2, so it will give you the behavior of the change. And then we are going to normalize that to 0, so if we have, let's say that we just move to the left, it will probably have negative direction, so we're going to normalize that in base of 0, so it will correspond to a matrix that if we get that information, we get the maximum and minimum, like the range of where the robot was working, and then with those two information, we're going to make a Boolean matrix, all false, and then with this information, we're going to put positive all the point at the robot take. So this is an example of how it works. Let's say we have this input, 3 south, 3 east, 2 northeast, and 1 north. So it will move 3 times to the south, then it will move to the east, so it is rotating, so it will count. Then we have to east, then one northeast. The first incident, it will assume that it is duration. So that's why we don't show this one, and then we show northeast. Again, at north, it will assume that it is making the duration, and then we'll say the north. So this is a sample input of what we should be expecting from the robot. It will be some kind of this time stream. So let's say we made the same string that mentioned above, to south, to east, northeast, and to north. And then we go to the plotted map. You will have it to south, to east, then the northeast, and then north. So it will show you where the robot moves.
This is actually an example of what actually the robot is sending. He's sending hexadecimal, and as you see here, this is all the hexadecimal that he's showing. That hexadecimal we converted to north, east, south, north, south, what Antonio explained to us. This is an example of what real thing is showing the software that we develop in our system. This is all the input, and this is the map for all that input. It's a video showing what the robot can do. Basically, you see here that when he show something in his front, like 1 feet approximately. He's doing a right turn. That's what he do. He see if it's something in the front. If it's something in the front, go to the right. The next one we're going to see. Next one is the software actually running. Here is the start button, and he's going to take all the information. This information is from the robot. Then we were done. Close the port. This is all the information that we take. Go to the graph, and this is what that info shows. Our conclusion, we successing in our design, doing this experiment with this Mark 24, this card that run and take information and send it to our PC via RF. And in the future, the user will have the ability to take that robot and put it in any place, and he will show you like a map of this. For us, like future work, will be nice to have not 2D graph, like a 3D graph that you can show what is in the floor, and where it is going to actually going from the car, or all that relation, and get the road pretty well. One other thing is to show the map actually a little bit better, but until now we think that we succeed in our experiment, in our design. Thank you very much. Any questions?